Hey, Math 7. I'm here to help with writing equations with one variable. So writing expressions would have been something that should have worked on in sixth grade. We can definitely continue to work with writing expressions. We've talked about it a little bit in class, but here I want to look at some real life situations and how we can write an equation to represent that situation. So I'm going to look at one-step and two-step equations here. So if you look at this, I have several different things going on. Okay, and really, I'm just trying to kind of give you steps to get to the end goal of C, being able to write an equation and use that equation to solve for a number of different things involving the situation. So the question here reads: Heather works at her job and earns $7.50 each hour. Create an equation to show the connection between the hours she works and the total cost. So first off here, one thing that you're going to have to get used to me saying is define your variable, which means this let me know, okay, say what your variable represents. So here you can see I give you H. H, okay, represents the number of hours, is what we mean by defining our variable. So H stands for the number of hours. So if we think about, and so a good first step is to sometimes think about in terms of a table, okay, how much would she make for if she worked 0 hours, 1 hour, 2 hours, 3 hours, 4, and so on and so forth. Okay, we don't have to go on forever because eventually we want to represent the number of hours, which is this column, with H, so that we can solve any number of different questions involving Heather and her job and the number of hours that she works, as well as the total. Shouldn't be cost, actually, it should be total profit. Sorry about that. So it should be profit because she's not paying to work. That'd be awful. So $7.50 each hour. You got to think, okay, if she worked $0, how much would she make? Well, she would make $0. If she worked 1 hour, she would make $7.50. If she worked for 2 hours, she would make $15. Okay, and if she worked 3 hours, right, she would make $22.50. Okay, and we would keep going on and on with this. Okay, to where eventually, okay, we want to think, what am I doing to the number of hours to get the total profit that the amount of money that she's making? So 0 multiplied by what will get you 0, and 1 multiply, or sorry, I should say not suggest multiply. This is a proportional relationship to where we can do that, but we're thinking, what am I doing the number of hours to get this? So this is a one-step equation. So we're only really doing one thing. We're multiplying each of these. So you're multiplying this left-hand column by $7.50 to get the right-hand column. So that's what you can do with H. You can say, I'm going to multiply H by $7.50. So $7.50 multiplied by H can be written like this. So that's what we're looking for in B. So write an equation to describe relationship between the total between the hours and the total. Again, should be total made. So if I'm looking at this is I'm going to be saying $7.50 multiplied by the number of hours. Now, how can I show that with, again, using variables? You can do 7.5. You don't need the 0 there, but you can have it. Multiplied by H is equal to her total amount made. All right, so then, okay, what's going to happen is we're going to be writing equations with one variable. Okay, so you're going to be given the total. All right, so it says, okay, we're told that Heather made a total of $240. Create an equation to solve. So I'm going to leave this part. So $7.50 multiplied by H is equal to $240. So now that's my equation in which I can solve for H. But again, I could have a whole bunch of different equations that we could solve. If I would give you H, I could figure out how much she made. If I gave you a different amount that she had made, we could find out the number of hours that she worked. So on C here, all you have to do then is solve the equation. So we've been working on that. The opposite of multiplying using inverse operations would be to divide. So I divide by $7.50 on both sides. And 240 then divided by, oops, I can get a calculator to work. 240 divided by $7.50 is going to be 32, which then means that H is equal to 32. But H here means something, okay? We can go back to what we define the variable as. H is the number of hours. So it means that she worked 32 hours. All right. to make $240. So that is representing a situation that is a one-step equation, okay, with an equation. So again, your main goal here is going to be C. So again, A and B are kind of just steps to help us get to C. Your main goal is to be able to write this equation that I have written right here, because you want to be able to represent real life situations with an equation. So what I want you to do now is that again, you should be taking notes down and making sure that you can do this while we're in class. But I want you to give it a try with this problem. So in this one, Max and Jim are running at the same speed. Jim has a 20-foot head start and is always this same exact distance ahead of Max. All right, so let's say that Max's variable is, so this is Max's distance. We'll say that this is M. All right, so M represents Max's distance. Okay, you're going to think about what would Jim's distance be, okay, based on these numbers, based on Max's distance. Okay, how would you write that with an expression? And then if Jim is 80 feet from the starting line, create an equation, see how many feet Max would be, and then solve that equation. So you're going to answer a few questions about that now. So looking at a two-step equation now. So one-step equation, okay, just means that there's going to be one operation acting on your variable. In this equation, there's going to be two operations acting on a variable. So Sammy has $35 in her bank account. She deposits $15 per week into the account and continues to deposit the same amount each week that follows. So again, a table can be very helpful, but really the first step here is to identify our variable. What are we looking for? Right. So many times what we're looking for will be in question C, or in the question once we start putting this all together in class. Okay. So if you look at this, it's gonna ask if she has $215 in her account, create an equation to find how many weeks she's been saving. So I tell you that here as well, but we know that the thing that is unknown, the thing we're looking for, is the number of weeks. I'm going to use W. All right, so the variable W, and now if we're looking at this, okay, and trying to solve, okay, at 0 weeks, okay, how much will she have in her account? So this is different than the last problem that I had shown you completely, to where she starts with money in her account. So she has $35 in her bank account, which means at 0 weeks, she has $35, not $0, 35. But then every week that passes after that, she's going to be adding $15 per week. So I know that here, week 1, okay, she starts with 35 plus the 15 that she made in the 1 week. So that's going to be 50. Okay, then we continue that with 3 and 7 and so on. So again, think about if she worked for 3 weeks. If she worked for 3, or if she deposited for 3 weeks, not necessarily working, or she's saving up her money, but looking at this, is 3 weeks she saves up. 3 multiplied by 15 is how we'd find out how much money that is. So 3 multiplied by 15 is 45. 45 added to the 35 that she had in there originally is going to be 80. Okay, we do the same then idea for 7 weeks. So we knew that at 7 weeks she already started with $35 in there, but 7 weeks, how much would she have deposited just in the 7 weeks? So 7 multiplied by 7 multiplied by 15. Oops. It's going to be 105. So 105 added on to the 35 is going to be 140. So now I'm trying to figure out this expression, which again, that's gonna go here. Okay, I'm thinking, what am I doing to the number of weeks each time to get then the total of the amount of money in the account? So if you were listening, okay, I was multiplying the number of weeks by 15, because that's how much she saves per week. So that's our rate. All right, so then I'm going to multiply the number of weeks by $15 to find out how much she has saved up since starting. But we also have to add in the $35 that she originally had. So that's why our expression would look like this. 15 multiplied by the number of weeks, which again, you can use the dot, don't use an X. 15 multiplied by the number of weeks plus the $35 that she had in the account originally. So this expression represents how much money she will have in her account for any number of weeks. So if we wanted to find out how much money she's going to have in her account after 50 weeks, doing the same exact process, we would be able to put 50 in for W and find out how much money is in her account. So we can go that way, or on C, to where if we're asked to solve for W, solve for the number of weeks, we're told that she has $215 in her account, and that we want to create an equation to find how many weeks she has been saving. So now we're told how much money is in her account. So 215 is going to go in for the money that she has in her account. So that goes in right here. So it goes in for the total. And then I'm just rewriting. I know that 15 multiplied by the number of weeks plus $35 would be equal to the total amount that she has made. So our first step here would be to use inverse operations to undo addition subtraction. So I want to undo adding 35 by subtracting 35. I'm going to do that on both sides. And I get then, again, isolating my variable W. Right? So I'm getting 15W all by itself on the left side is equal to 180. And then I'm going to then undo the multiplication of 15 by W by dividing by 15. So again, opposite of multiplying by 15 would be divide by 15. So then divide both sides by 15, and W, I'll put it over here so I don't run out of room, is then equal to 12. All right, which again means that Sammy, she has been saving for 12 weeks. All right, so again, that's what W is equal to 12 means. So in a word problem like this, you need to be able to write an equation like I have right here, but you also need to be able to solve that equation and realize what your variable means in the context of the situation. So again, that's the kind of the difference between a two-step equation and a one-step equation. For the two-step, you're gonna when you have a zero number of weeks or a zero whatever it is, okay, that you're starting with a value. It could be positive, it could be negative, but you have a starting value. All right. So looking at the next problem here, it says Jessica is making bracelets and plans to sell them for $3 each. She has to spend $20 of her own money on making supplies before, of her own money on supplies before making the bracelets. All right. So we will say that B represents the number of bracelets. So B is our variable, and it represents the number of bracelets that she has sold for $3 a piece. She had to spend $20, okay, of her own money. Right? So she's essentially starting in the hole. That's kind of a hint for you. On C, she's trying to make a profit of $130. Right? And you're going to write and solve an equation to try to solve or to find out how many bracelets she would have to sell. So they're going to answer the few questions that you have here about representing this situation as well as solving the equation.